Okay, so in 8.6 we're going to look at springs and tension. Okay, now why do we want to look at this specifically? Well, we want to better understand contact forces. We have discussed contact forces, your foot on the ground, you sitting on the chair, pressing against the wall, your hand pressing against the wall, whatever, a tire on the road. These are contact forces. And in order to better understand contact forces, we want to study the behavior of a spring. Okay? So I want you to make this connection. To understand contact forces, we would like to look at the behavior of a spring. Okay? Because actually what you'll find is that everything behaves like a spring. Perhaps you don't believe me, but everything can stretch and compress. Just some things you can't see. They're very stiff. They do not compress, but they do compress to some extent, and they can also stretch. Okay? Okay, so we'll get to that in a minute. So we're looking at the behavior of a spring. Now let's get going. When a spring is neither stretched nor compressed, we say that it is at its relaxed length. Okay? Relaxed length. There's no force being applied to it. It's not being stretched or compressed. Okay? Now, let's consider a situation where let's look at this diagram. Here's the picture. So say now we have a spring on the floor and we place a brick on the spring. We know what happens. The brick compresses the spring until it is in equilibrium. Okay? So if we draw a free body diagram of this brick, we get this. Remember this, how do we draw a free body diagram? Okay, just ignore this one at the bottom now, okay? Ignore this one. Let's just look at this one here. So we draw the center of mass for the brick. Okay, we know that it's in equilibrium. Acceleration is 0. And what's actually happening is that the gravitational force is pulling the brick down, but the spring is resisting that downward motion with an equal and opposite force. Okay, so remember, force of gravity, that's G, earth on the brick. So this is the gravitational force. And then we've got force, C is contact, and it is spring on brick. Okay, now, whenever we have something like this, where you have a brick compressing a spring and it's in equilibrium, we can call this a support force. Let's go back here. Okay? So this is called a support force. A support. Okay? So we'll see a bit later how this actually applies to everyday things. Okay. So in the same way, now let's look at this guy. So here we had the spring on the floor or whatever, and then we had the brick resting on the spring. The spring applies a support force to counteract the gravitational force, and it's in equilibrium. Acceleration is 0. In the same way, if we have a spring and we attach the spring to the roof, the ceiling, and we again attach the brick there, this is again in equilibrium. We have exactly the same free body diagram. We have gravitational force pulling the brick down, and we have the spring pulling the brick up. Again, the spring is acting as a support force. Okay? Now, one thing that is important to note is that anytime you compress a spring, it wants to resist the compression. So it wants to restore itself back to its relaxed length. And anytime you stretch a spring, it wants to restore itself back to its relaxed length. Okay? So, forces exerted, let's read this. The force exerted by the spring always tends to return the spring to its relaxed length. Forces exerted by springs are therefore called restoring forces. If you want to compress it, it wants to resist you. If you want to stretch it, it wants to resist you. Okay? So it's always trying to move back to its relaxed length. This is a very important point. Okay, see you in the next video.